Hi everyone, and welcome to today's live stream. So today we're going to be talking about bridges. First, I'd like to thank our sponsors, Promo Science and Actua, for making all of this possible. And well, let's get started. So we're going to talk about engineering a little bit for you first. So there's lots of different types of engineers. One type is a chemical engineer, and chemical engineers do lots of different things. They create commercial products, specific chemicals for industrial purposes. Civil engineers, like people who build bridges, they design different structures like roads and buildings as well. Mechanical engineers design and create machines to complete tasks. And electrical engineers, they work with circuits and technology. So we're going to talk a little bit more about civil engineering and bridge building specifically. So what does a bridge do? Well, bridges span gaps so that we can cross them, like bodies of water such as oceans and rivers, as well as valleys and ravines, places that we couldn't access or cross easily with just us or a vehicle. Bridges also change how force acts on the bridge by spreading it out or focusing it to the strongest point of the bridge. So let's talk a little bit more about force. Force is equal to mass times acceleration. And this is Newton's second law. Pictured right there is Isaac Newton himself. So force is measured in newtons. Mass is measured in kilograms, and acceleration is measured in meters per second squared. And all that means is that the amount of speed it gains with each second. So meters per second. So acceleration due to gravity here on Earth is 9.81 meters per second squared, which means that if I take an object such as this pen and I drop it, the pen accelerates at 9.81 meters per second. So 1 second after I dropped it, its speed is 9.81. 2 seconds after I drop it, its speed would be about 19.6 meters per second. So 1 Newton is the amount of force required to accelerate 1 kilogram object 1 meter per second every second. So pictured here is the type of forces that we might see in our bridge. So the force created by a car or a truck or a person pushes down on the bridge, and then the top of the bridge compresses. It's getting closer, it's pushing into itself, and the bottom of the bridge is experiencing tension, pulling. So each different type of bridge experiences these forces differently. And today we have 6 different types of bridges, and each type of bridge was created by a member of the X-Chem team here. So let's just talk about a few of these. So first up is the beam bridge. So it's one of the simplest bridges. It's very easy to build. So it just has a couple beams across the top, and it has legs in between. So the legs actually support most of the weight of a beam bridge. And they're great for small gaps or large gaps. They're very versatile bridges. Secondly, we have an arch bridge. So there's no legs on an arch bridge, as you can see. And the tension forces are already there because of the bottom part of the bridge, the actual arch of the bridge. So these bridges tend to resist compression forces. They're harder to build and are only good for short spans, and they're better for valleys and stuff because we don't need to build giant legs down to the bottom. Next up is a truss bridge, and you may be familiar with this type of bridge. It's very common. and it uses triangles. Triangles are one of the strongest geometric shapes in nature. So it's got sides. This bridge has sides on it, and it can spread its force out more. And they're very, very strong. So next up we have a cantilever bridge, pictured in the bottom left corner here. And they have structures that project horizontally into space, supported on one end. Again, this is a very large bridge and very expensive to build, but it is a very, very strong bridge. Next, a suspension bridge, a very popular bridge. You may recognize this type of bridge as it's the Golden Gate Bridge in California from Oakland to San Francisco. And they feature cables that hold the weight and transfer it to the towers. And finally, we have a cable stay bridge. And the cables transfer weight to the anchors, similar to a suspension bridge, except instead of long cables running across the top that go down, we have many cables that protrude from the towers that connect to the bridge. So, with all that being said, let's start testing our bridges. And if there's any questions, feel free to ask, and I'll do my best to answer them. So with me here, I have a few different just hand weights here. This one is 2 pounds, so 1 kilogram is approximately 2.2 pounds. So this is a little less than a kilogram. So first up, we have our beam bridge. This one was made by myself, and it's got a few flags for decorations. As you can see, it's a pretty simple design. So let's put it and see how much it can hold. So I'm going to start big. Let's go with 5 pounds. Oh, good so far. Put a bit more weight on it. Put 2. I'm going to try to spread our weight out as much as possible. Oh, that's 9 total pounds. So let's take these off. Let's go for 10. Just stack that right on top. Oh, here's some creaking. That's not good. 12. Oh, 14. Wow. Doing good here. And of course, we all have a gap to span here, so we have some wood blocks to balance our bridge on. 16. Quite impressed with myself. 18. Wow. So now we only have 1 pound weights to add. Well, there we go. That's all 22 pounds that I have. Give it a few seconds to see. I can see here in the middle, it's got quite a bend in the leg, but it's still standing. Wow, good job me, I guess. So let's move on to our next bench. Maybe we'll come back and see how much we can put on this. next up, let's try our arch bridge. And the arch bridge was made by Taylor. So, very beautiful design, very structurally sound. She even was able to create the arch out of the popsicle sticks. So let's go right for the 5 again. Good so far. And another 5 on top. How am I going to get more from here? $12, $14, $16, there's 18. There's a little bend in the middle here, but it's still doing great. There's 19. 20. 21. There's quite a stack going on here. And 22. Wow. Great job, Taylor. That's great. Well, hey, that's 2 bridges that survived all 22 pounds so far. So 22 pounds would be about 10 kilograms. For those of you that don't have a calculator close. So next up, we're going to do the arch bridge. So here's an arch bridge. This was built by Kyla. You can see, simple design here. So let's see how strong it is. So we'll start with 5. So far, so good. And maybe this time we'll just go with 2. So 2 looks good. Try 2 more. That'll give us 9. Pretty difficult too. So just 10. 11. Good so far. Let's go. I'll switch sides. And that's 13. I got some popsicle sticks falling off now. Harder than it looks to get all these on there, but it's holding up so far. 15. And 16. All right, let's take a few of these off. So this will be 16. I took 5 pounds off and then replacing it. So 16, 17, 18. Where do we go from here? 20. There's quite a bend in it. A few popsicles. Oh. Should we put the last 2 on? Let's put the last 2 on just to see what happens. There's a few more popsicle sticks that are breaking. It's quite a lean on the bridge right now. Oh no. So we had 20 pounds on that one before it fell down. Just go a few here. You can see the carnage. So 20 pounds. Still, great job. So our next bridge is a suspension bridge. And this bridge was built by Josie. So let's raise the X-Chem flag, and we're ready to test this bridge. So do you think this bridge is going to hold all 22 pounds? Let's see in the chat. So let's see, let's start with 5. Okay, got 5. Let's go with 10. So that's 10. 12. 14. 16. 18. 19. Well, it doesn't even look like the bridge is bending or anything. It's pretty good. 20. And 21. And 22. Great job, Josie. That's a fantastic bridge. Worked well for the stacking. So that's another one that survived. So our next bridge is a cable stay bridge. This one was made by Cali. And you can see some more flags on there and the typical cables that are connected to the bridge, the towers, and legs. So let's try Cali's bridge. So there's 5. Oh, whoops. There's 10. So that's 10 pounds. And there's 12. We get quite a bit of flex in the bottom, a lot of tension along the bottom here. 14. 16. 18. I think if we learned anything here today is that the X-Chem team are great engineers. Oh. Well, there you have it. Not a catastrophic failure, but the tower did break. So we got up to 16 there, so still a great job. So we have one last bridge here to test, and that is our cantilever bridge. That bridge, as you may have seen in the thumbnail, was built by Caitlin, and it's quite the bridge, a great looking bridge. Our biggest bridge of the day. Yeah, rest in peace, Callie's bridge. Had a great run, a great run. So let's try it out. So 5. 10. Doing great so far, not even a bend or a creak. So there's 12. 14. 16. 18. We get a bit of flex with the legs here. afraid to let this one go. I told her I wouldn't break this one. So. Could be the straw that broke the camel's back, I'd say. But yeah, this bridge is it's about to go down, but it's too pretty to see to break. So I think we'll save this one, but I'm going to call it at 18. So that does it for all of our bridges, guys. So great job to everyone who built a bridge. And is there any questions about force or about bridges? I'll just stay on here for a bit. And once again, thanks for tuning in today, and thanks to the X-Chem team for doing a great job building all these bridges. And so this is our last live stream of the week, and don't forget to tune in next Tuesday for our next live stream. All right, so it doesn't look like there's any questions, so that'll do it for our video today. Thanks everybody for watching, and have a great day.